All right, this is going to be page 20 of math analysis. We skipped the last two pages in video form, but you can see I did start working on a solution. So maybe that exists in the description of the previous video. Maybe not, I don't know, depends. So let's see what this one says. So we're going to talk about cofunctions. So cofunctions are going to stay with us like forever once we understand them. And they're not super hard to understand, so this is awesome. So let's see if we can do that. So first I want to draw a right triangle ABC with these things. So let me first draw it. Also, I discovered in the interim that I think I can like just kind of go for it and it snaps into a triangle, and that's awesome. And I can't believe I didn't realize that earlier. So I have this, and the only thing I need to worry about is it doesn't really matter where I put the 5 and the 12. What does matter is where I put the 13, because it's the biggest side of a right triangle. It's got to be the hypotenuse. So this has to be 13, which means this has to be C. I feel like it just makes sense to put A here and B here. So A, opposite that is 5, and then 12. All right. Now, what do we want to do? List the list the 6 trig. Oh, because it was 6 trig. List the 6 trig functions of each of the acute angles. Okay, so let's go with sine of, I'm going to go with theta, and then theta could be A, theta could be B. Cosine theta, tangent of theta. Then cosecant of theta, secant of theta, cotan of theta. You just want to write them a lot. The more you write them, the like faster you can kind of reel them off. All right, so let's see. Sine of angle A, opposite is 5, adjacent, opposite is 5, and hypotenuse is 13. So it's going to be 5 over 13, but that means adjacent must be 12. So 12 over 13, get out, 12 over 13. Then tangent is going to be, oops, crashed it. Like fatally crashed it? No, not fatally crashed it. Okay, so it's going to be 5 over 12, opposite over adjacent, and then we flip 13 over 5, 13 over 12, and then 5 over 13. All right, and then we want to do the same sort of thing for B. So sine of B is going to be 12 over 13. So I'm looking at the triangle, and then 5 over 13, and then 12 over 5, and then flip. So this will be 13 over 12, 13 over 5, and 5 over this. One of these is wrong. There's 5 over this one right here. You should be at 12. 5 over 12. Nope, 12 over 5. What am I doing? I'd love to go, well, I'm not going to, but I'm curious if I went back and saw, like, did I say the wrong thing too? Probably. 12 over 5, and then 5 over 12. Okay, so what do we want to do? Looking at the table, identify the pairs that are equal to each other. So we have certain pairs that are equal. I'm going to try to highlight. So let's say we got 5 over 13. Here's another 5 over 13. So the sine of A equals the cosine of B. So sine of A equals cosine of B. Good. Next color. We're going to need a lot. 12 over 13, 12 over 13. So that's the cosine of A equals the sine of B. Cosine of A equals the sine of B. All right. Let's look for our tangents here. So 5 over 12, and then 5 over 12. So the tangent of A is equal to the cotangent of B. Tangent of A equals cotangent of B. All right, so far so good. And I think there's probably 3 more. So here, cosecant of A, secant of B. And then let me just keep going while I'm here. Secant of A, cosecant of B. Maybe it makes sense, I don't know. It seems to fit a pattern. And then cotangent of A, tangent of B. All right, so let me write those down. So cosecant of A equals the secant of B, the secant of A equals the cosecant of B. So what are we doing? We're like figuring out that some of the ratios are equal. And it looks like, I mean, if you read them, what am I doing? Tangent of B, sine of A, cosine of B. Cosine of A, sine of B. Tangent of A, cotangent of B. Cosecant of A, secant of B. Secant of A, cosecant of B. It's like I'm better at enunciating when I start with the non-cofunction. So sine goes with cosine. Tangent goes with cotangent. Secant, cosecant. So now the question becomes sort of like, what does the co stand for? And we can kind of get that from here. What is the relationship between the acute angles of a right triangle, right? So what do they have to add up to? So let's say if A and B are the acute angles, so acute angles of a right triangle, and you can abbreviate the way that I abbreviated that, then A plus B equals 90 degrees, or pi over 2, depending on what you're doing in life. Therefore, A and B are complementary. So complementary. Now, look at that. Complementary. That's where the co comes from. It's complementary. It's a relationship. Complementary sign. Complementary tangent. Complementary secant. It's almost like sine, secant, and tangent are like the ones that should exist, and the other ones are just co-functions. Do we really need them? Probably not. Like we could make do without them. So now, why are they equal? So I'm going to just explain one of them, right? So if we look at this side A. So the side A is opposite of angle A, but it's adjacent to angle B. So let's say, since side A is opposite angle A, but adjacent to angle B, the sine of A is going to be, let's say, A over side C, A over C, which is equal to the cosine of B, which would also be A over C. So that's the reason. It's because the same side in the triangle has two relationships. It's either opposite one of the acute angles or adjacent to the other acute angle. And it doesn't matter which one you pick, like that'll keep happening. So that's why we're getting these relationships where they're equal. So actually, we can say down here that, and how much is left on this? Yeah, I'm gonna finish this page. I'm just gonna go for it. Let's see. So the cosine of x is equal to the sine of, I'm gonna do 90 minus x, or the sine of pi over 2 minus x, because we don't know if we're in degrees or radians. Cosecant is equal to the secant of 90 minus x, or the secant of pi over 2 minus x. And then we can keep going. So this will be the tangent of 90. So this is like interesting information. I use it a lot. In my experience, my students use this information less than I do. You should strive to use these pieces of information. They're really useful. The problem is you won't see that many examples until you get to calculus where you can use it. And then it'll make your life a lot easier to think about it. But, we'll do our best. I will have done my best to write problems that will force you to at least think about it a little bit. I mean, that's my goal, at least. Is it mission accomplished? Not 100%, but I tried. And there we go. Okay, so these are cofunction identities. You've got to know these. These are a big deal. Can I box around them? I have no luck like making a box. I really believe that this should work. Like if you can make a triangle. Why can't you make a box? Let's do this. At least I can like snap the edges and get like a nice crisp kind of highlight going around. There we go. Okay, gotta memorize those. Those are your cofunction identities. Let's like use them. So you're not gonna use them for much here, but if we know the sine of 15 degrees, then for example, we automatically know that the cosine of 90 minus 15, which is the cosine of 75 degrees, is also approximately 0.258819. Went with a lot of decimals there. The other thing you know kind of for free, meaning like you don't have to do a lot, if sine of 15 is that, then cosecant, the reciprocal, is just 1 over that. Well, as approximately, I guess. Like probably way more approximately, because you're dividing by a crazy decimal, but still. 8819. You actually know all of the trig, almost, for reasons that aren't really clear. You don't obviously know all of them. Well, actually, in this case, you do. Don't even worry about what I was saying. You kind of know all of them because you can do your thing. You can draw a triangle, work with that. What about this? So if cosine of x is this, then the sine of 90 degrees minus x is also 0.25, and there's like nothing more we can really do with that. But cosine, its reciprocal is secant, so I also know the secant of x is 1 over 0.25, which is definitely 4, but like, why bother, you know? So I use these a lot. You got to think about them. So it's just, they match up cos, like it feels right. Sine, cosine, secant, cosecant, tangent, cotangent. Like, not hard to remember because the co is basically for complementary. Think of the complement, and then you've got it together. So what I'm going to do is end this video here, come back in the next video, probably finish up this set of notes, maybe. Actually, I don't know what's on the next page, but I hope to see you there.